Hi, good afternoon. Shavi Beta, you doing okay? You might be on mute. Okay, let's start. Um, so yesterday we worked with the vectors and we did quite a few questions wherein we tried to figure out the angle between the vectors. Then we dealt with another 10 or 11 questions requiring your use of the general vector algebra. Okay. Any questions from that discussion, from the discussion yesterday? No questions. Okay. So today we will be covering question type number 16, 17, 18, 19, 20. We will change the format a little bit. So what I'll do is I'll cover the theory of these question types. In other words, what are the involved concepts and how to use them. I'll try and solve perhaps one question as a sample, and we'll keep moving. And if I try and let's say wrap it up in the another maybe 30 minutes, 40 minutes, then we would have plenty of time left for solving questions. Okay. And I might ask you guys to solve perhaps one question or at the most two questions in between as well. But I'll try and keep the questions for the last. Okay, so what I'm going to cover in the 16, 17, 18, 19, 20. So 16 and 17, we essentially are going to play around with the definitions of velocity, displacement, velocity, acceleration in two dimensions. Okay. Number 17 is a very specific, interesting scenario where we have a particle moving along a circular path, and we will try and understand what is the change in the velocity vector between any 2 points. In other words, we will try and figure out the average acceleration for different durations of time. In other words, for 15 and 16, we will try and make ourselves comfortable with the definitions of the velocity, displacement, velocity, and acceleration in two dimensions. Now, 18, 19, and 20 is where we're going to have a lot of good fun. Not to say that 16 and 17 are not fun. They are fun, they are important. But 18, 19, 20, from the JEE mains as well as JEE advanced standpoint, looking at the 2021 paper, 2022 papers, this is something to be paid attention to. Here we'll be dealing with the relative motion in two dimensions. Okay. Any questions? If not, then I'll get started. Yes, please. Any questions? No. So let me go ahead and get into number 16. And just to get the conversation going, Ruchika Beta, were you able to solve that one question that we left out in the general vector algebra from JEE Advanced, one of the years 2017, 20, whatever that year was? Were you able to solve that?
It's slipped my mind. I forgot to do it.
Okay, okay. I would recommend that you should do it. Try and just do it at the end of the class. Take 5 minutes. It should not take more than 5 minutes. Okay.
Yes, sir.
Okay. Chavi Beta, were you able to do it? You're not able to. Okay. That's fine.
Sir, I forgot.
That's okay, Beta. That's okay. My job is to remind you guys of certain focus areas. Let me do this. Let me just zoom in a little bit. Okay. So we are now entering into two dimensions. So let's recall that in the very first question type that we worked with in one dimensions, right? So I'm just going to revisit what we discussed there. So we said if you are given the position, let's say x, as a function of time t, then you can figure out the velocity and acceleration. How do we do that? For velocity, we will take derivative of x with respect to t. Now, both you guys are comfortable with the derivatives. But if you were not, so it's not that difficult. I think we have spoken about what it means. What does the derivative means? It essentially tells us if you change the time by small amount dt, what will be the change in x, right? So how much will be the displacement in time dt? So the rate of change of displacement is your velocity, dx by dt. Now, as far as the acceleration is concerned, it will be rate of change of velocity, dv by dt. Recall these are all vector quantities, but we were dealing with one dimensions. So the way we represented our the vector form, and what's so special about the vectors versus scalars? Vectors have magnitude and direction. So here we dealt with direction by either recording plus or minus, depending on which way was your coordinate axis. If your coordinate axis, positive coordinate axis, was along the right side, then any displacement in the right hand side was taken as positive. Anything on the left hand side was taken as negative. Now we are getting into two dimensions. Now, by the way, the plots that we dealt with in the one dimension motion, we always had time along the x-axis, and along the y-axis we either had your position or velocity or acceleration, right? But here you might have the x coordinate or the y coordinate, or you might be plotting something else with respect to time, right? Like say the magnitude of v with respect to time or whatnot. But this is x versus y. What is x? X is the position of the particle at time t, the x coordinate measured along the x-axis, and y is the y coordinate, or the y-axis is pointing upwards, and the particle, if the particle is somewhere, let's say at point A comma B, then what it tells us is that with respect to the chosen coordinate system and the chosen origin, the particle is at a distance A away along the x-axis and a distance B away along the y-axis. Okay. And what is the position vector for such a scenario? Position vector of the particle will be, in this case, ai cap plus b j cap. This will be my position vector. Okay, good enough. Now, what is the velocity? So what is the velocity? In two dimensions, we can write it as dr by dt. What is dr? dr is your displacement. dr is your displacement in two dimensions, right? Displacement vector divided by the time duration. Displacement vector divided by the time duration. So let me actually redraw this plot. Let me just redraw this plot into a little bit of an open space here. So let's say that the particle is moving like this, right? This is, once again, this is your x and this is your y. The particle is moving in a two-dimensional, or it's moving in a plane. Now, let's say at time t equals to 0, the particle is here at point A, and after certain duration delta t, the particle is at point B. Right? Then let me just correctly draw it. So what will be the displacement? This will be the displacement. Correct, Nabita? This will be the displacement. This will be the displacement vector. Let's call it delta r. This was the position vector at A. This was the position vector at B. Delta r is nothing but the final position vector minus the initial position vector. Delta r, the displacement, is nothing but the final minus the initial. So in such a scenario, the average velocity would be delta r by delta t, average velocity vector. So I'm putting the arrow at the top just to indicate that these are vectors. Now let's talk about the instantaneous velocity. Instantaneous velocity. What do we mean by instantaneous velocity? So we mean, let's say that the particle was at point A. We want to find out what is its instantaneous velocity. Then it is the small change or the displacement in the time duration dt. In a very small time period, what will be the displacement? So if this is the position vector at t equals to 0 or at some time t, at t plus dt, let's say the particle is here. Let me draw the displacement vector using a different color. The displacement vector is this. This is dr. And the velocity vector is dr by dt. So what does it imply? That the velocity is in the direction of the displacement, which is logical, makes sense. dr by dt. Okay. Now, in the question type that we're going to be dealing with here, if you are given the position coordinates x and y as function of time t, then we might be asked to determine the velocity vector and the acceleration vector, which is, as I mentioned, we did something very similar in the one dimension, but let's do it here. How would we do it? So we'll say the r position vector is nothing but xt I cap plus yt j cap. Chavi, Ruchika beta, I think you guys are getting comfortable with such notations, but make sure that you practice this enough so that when we get into the advanced chapters, that this is something natural. You are not writing in the vector form or in the unit vector notation. It does not seem strange. So it will require some practice. Okay, so make sure you use any opportunity you get to practice such questions. So what will be the velocity vector? Velocity vector will be dr by dt. So when I take the time derivative, so we want to understand how does x change with time and how does y change with time. Correct, no? So dx by dt is nothing but the what we refer to as the x component of the velocity vector. Dy by dt is nothing but the y component of the velocity vector. So we have the velocity vector now. So I can write this once again as vx plus vy, where vx is dx by dt, vy is dy by dt. Now, acceleration vector is nothing but rate of change of the velocity with time, dv by dt. So that'll give us dvx by dt I cap plus dvy by dt j cap. So now this is what we call as the x component of the acceleration. This is what we call as the y component of the acceleration vector in the unit vector notation. Yes, in the unit vector notation, what's the component of the or the coefficient of the I unit vector? There's a unit vector along the x-axis that is called the x component. So that is ax. The other one is ay. Now let's revisit this particular example. So here what we are given is, we are given that x is a sine omega t and y is b cos omega t. So you might be you might be asked to determine the velocity vector. So what will be the velocity vector here? Dx by dt I cap plus dy by dt j cap. So what will be dx by dt? Derivative of a sine omega t. There will be a omega cos omega t I cap. What is dy by dt? Derivative of b cosine omega t. There will be minus b omega sine omega t. Right. Minus b omega sine omega t j cap. I should have written the velocity vector, not just Vx. So the velocity vector is this. This is the x component, and this is the y component. Okay. Similarly, we can take the double derivative, and we'll get the acceleration. So the acceleration vector would be minus a omega square sine omega t I cap minus b omega square sine omega t j cap. I can write this as, I'll take minus omega square out, a sine omega t I cap plus b cos omega t j cap. Any observations about the acceleration? Any comments, Peter?
So you wrote sine instead of cos.
Now looking at the expression for acceleration, comments here. Can you compare this with the position vector?
So it's minus omega square into position vector.
Correct. So if the position vector is, then the acceleration vector is the opposite direction. Now, you might be at times you might be asked to determine the trajectory of the particle. What do you mean by trajectory of the particle? Trajectory is the path followed by the particle, right? How do you determine that? Well, we're interested only in the path. We're not interested in time, right? So remove the time variable, and the equation that you will get in x and y, the trajectory equation. So for this one, it's fairly simple. Looking at it, we know divide x by a and then square it. Similarly, I divide y by b and then square it and add. So you will have on the right hand side, we'll have sine square omega t plus cos. This is the equation of ellipse. Yes, Vida?
Yes, sir.
Okay. Ruchika, beta, quick question. Is the velocity vector perpendicular to, is v perpendicular to position vector or the acceleration vector here? Or Chavi? How would you guys determine whether that's true or not?
So dot product लेके
डॉट प्रोडक्ट लेके फटाफट देख ले, मुझे बता दे. So if I were to take the dot product, we know this is not zero, right?
Yes, sir.
Correct, no? This is Vx and Vy. Just multiply it. What you will get is a square omega sine omega t cosine omega t minus the minus b square omega sin omega t cos omega t. If a is not equals to b, then that is not 0, which is what you would expect in case of ellipse, right? So this is the ellipse. This is the minor axis, this is the major axis. At these points, at the what in case of the elliptical orbits, we call it the far point and the near points, right? So at the far away points, this is perpendicular. It also is perpendicular. R and V. Here also the perpendicular, assuming that the particle is moving like this. But at any other point, velocity vector is not perpendicular. Can you see? Yes, makes sense? Yes, no?
Yes, sir.
हाँ, बीच में affirmation में थोड़ा सा time ना लगाए, so that we can quickly move on. Okay. Moving on. Let's go ahead and solve one question. Let me see. This is the 2022 question. Let's quickly look at it and tell me how would you guys approach it. And if you can figure out the answer, God bless you. The motion of a particle in the xy plane is described by a set of following equations. X is equals to 4 sine of pi by 2 minus omega t and y equals to 4 sine of omega t. What is the path of the particle? What is the path of the particle? To find the path, what did I talk about? Eliminate time. We are not interested in time anymore. Trajectory means tell me if x is this, what is y? So you need an equation in x and y. You don't need time t.
Circular.
What is it, beta?
So it's circular. A option.
Okay.
So I got the equation, but I think I've already told you this, but I'm not sure what is a circular equation, like which is electrical equation.
Oh, what is the equation of a circle?
Yes.
Equation of a circle is x square plus y square is equals to radius per square. So let's quickly establish the equation of a circle. If you're moving in a circle, this r remains constant.
Yeah.
So if you are at an angle theta, your x coordinate is r cos theta. Your y coordinate is r sin theta. Yes, beta?
Yes, sir.
So x is equals to r cos theta. Y is equals to r sin theta. Now we want an equation in x and y. We don't use the stranger here. Who do we want to throw out, right? Not to say we should throw out strangers, but we want to eliminate theta, right? So just square them up and add. What do you get? X square plus y square is equals to r square. Correct?
Yes, sir.
So this is the equation of the circle.
Yeah. So then it's a circle.
It's a circle. And what is the equation of an ellipse? X square by a square plus y square by b square equals to 1. If, and what is a and b? We drew an ellipse there. This is A, major axis. This is B, minor axis. If A is equals to B, then it becomes a circle. And you can see if A becomes equals to B, then you will have the equation as x square plus y square is equals to A square. Correct? It becomes a circle. Equation of circle. Parabola we have already spoken about. He said the y is equals to, or 4ay is equals to x square equals to 4ay, or y square is equals to 4ax, right? We spoke about those equations, right?
Yes, sir.
Okay, good. Take a quick look at this equation. Tell me how you guys going to approach it. I don't want to spend too much time on this, but I want to hear a very clear sound approach. Chavi beta, I'll let you think out loud, okay? And then Ruchika beta, you be ready. I'm going to ask you a few questions on this as well. Position vector is given cos omega t I cap plus sin omega t j cap, where omega is a constant and t is time. Then they are saying, can you comment on the velocity, the acceleration? We'll talk about the velocity and acceleration. So Chavi, think about it, beta. Ruchika beta, this is the, what is the trajectory? What is the path, equation of the path followed by the particle here?
So x square plus y square is equals to 1.
Yes, that is a circle. So the particle is tracing a circle of radius 1, whatever the unit is for distance. Let's say this is 1 meter. Okay. Now you can very well tell right away from here that V will be perpendicular to R and A will be directed towards origin. Yes?
Yes, sir.
But do it from the vector algebra. How would you do it? Chavi beta? Just speak out loud the steps, and I'll fill in the spaces.
So to find the velocity and the acceleration, you have to differentiate and then double differentiate. And then to find if they're like perpendicular, you have to take dot product, and if it's equal to 0, you know it's perpendicular.
Yes, beta. So let me just quickly write down what you just said. You said V is equals to dr by dt, which is minus omega t I cap omega cos omega t j cap. The dot product R dot V, got it. I can tell from here this is right. Why? Because you will have minus omega sine omega t cos omega t plus omega sine omega t cos omega t. That will be 0. That means R and V are perpendicular. Now, as far as the acceleration will be minus omega square cos omega t I cap plus sine omega t j cap. I have skipped one step, but I'm sure you got it. Now, this is nothing but the R vector. So if somebody writes a vector A as minus some positive constant A, which is omega square, into, so what does it tell us? That vectors are in opposite direction to each other. Correct, no?
Yes, sir.
So R is pointed away from the origin. Remember, position vector always has its tail at the origin and the head at the location of the particle. Acceleration seems to be the opposite direction, so it must be directed towards the origin. Clear, beta?
Yes, sir.
Okay. Now I'm going to make use of this opportunity and talk about the relation between the magnitude of the acceleration, magnitude of the velocity, right? So in this scenario, can somebody tell me what is the relation between the magnitude of the acceleration and magnitude of the velocity here? What is the magnitude of velocity? Which I can write simply as v. Magnitude will be vx square plus vy square under root of that. Yes? Del
Yeah.
3 omega.
Yeah.
Okay. What will be the magnitude of acceleration?
Omega square.
Omega square. Now, if we had instead of the radius being 1, if we had it a, then everywhere you will get a. Let me just quickly check something. Okay. So then it will be, acceleration will be omega square r, or omega square a in this case. And we can write, and this will be omega a. So we could also write this as v square by a. Remember this, acceleration, when a particle is moving along a circle, it has a centripetal acceleration, that is acceleration pointed towards the center, and its magnitude is v square by r. We will talk about this in quite a bit of detail in one of the upcoming question types, where I'll show you both algebraically as well as graphically why that is true, right? But a equals to v square by r, with over a period of time, this will become part of our DNA, at least for 11th and 12th. Okay, moving on. Let me go to the next question type. Is the pace okay? Is it slow? Is it fast? Ruchika beta, you're okay with the pace?
Yes, sir.
Chavi beta, is the pace okay?
Yeah, it's fine.
Okay. The particle moving along a circular path, at, let's say, constant speed, what are we trying to practice here? We're trying to practice the definition of average acceleration, right? Or average velocity for that matter. Okay? So let me just zoom in. Hope you guys can see it better. So let's talk about the average velocity. Once again, V average is final position vector minus initial position vector divided by the time duration delta t, right? Nothing too funny about it. Fairly simple and straightforward definition, similar to what we had in dimension motion. Average acceleration is also Vf, final velocity, minus initial velocity divided by the time duration. Okay. Now, if the particle is moving at constant speed, that means that the magnitude is the same. Then what is the average velocity? If the particle starts at point A at t equals to 0 and it reaches point B at time t1, C at t2, D at t3, and comes back here at A at t4. So for the between A and B, over the duration, over the this duration T1 over T1, what is V average?
B minus A by 1 D1.
I need to give you certain information. This is radius R, right? This is radius R beta. Speed is V. Now tell me. Give me in the position in the vector format. Well, let's start with the displacement. Over the period T1, the displacement is how much? Is this the displacement vector? Yes, beta?
Yes, sir.
And
Yes, sir.
its x component is this, its y component is this. So can I write this as minus r I cap, assuming that this is my positive x-axis and this is my positive y-axis. So minus r I cap plus r j cap. Can I write it like this? Just check, please. So now what we are saying is keeping coordinate system at that point at t equals to 0, that is at A, your displacement vector is pointed towards the if I were to this is the northwest, right? What is the projection of this along the x direction? Minus r. What is the projection on the y-axis? It's plus r. Yes?
Yes, sir.
So the average velocity would be delta r divided by delta t. This will be delta t minus I plus j cap. Simple, straightforward.
Yes, sir.
Okay, Ruchika,
Clear, sir.
you know. Now, what is the average acceleration here? Ruchika, what I'm going to ask you now. Give me the vector in the average acceleration in the vector notation. The speed is v. By the way, sorry, I'm going to interrupt you, Chavi. What is delta t? Can you express delta t in terms of radius r and speed v? Is it this circumference or the length of the arc, this arc, which is pi r by 2, and the speed v, distance divided by speed. Is it delta t?
Yes, sir.
Okay. Yes, Vida Ruchika, what is the average acceleration here?
So it will be minus VBI minus VAG divided by dt.
So minus v I cap. What
So minus VJ cap upon dt.
correct, Beta?
Yes, sir.
Chavi, Beta, is it clear?
Yes, sir.
Average acceleration, nothing but final position vector minus initial position vector. What is the position vector at B? Well, the velocity is towards minus x. Magnitude is v. So this is your Vf. What is Vi? Vi at this point A. This is V pointing towards the y-axis. Use the minus sign, you get the minus sign. Correct?
Yeah.
Okay. Now, what is the, I'm going to just skip it over because you can repeat the same exercise for point C and point D. Let's talk about when it reaches A again. So over the duration T4, over the duration T4, so that means when the particle makes one complete revolution, what is its displacement, net displacement? What is the net displacement? Yeah, beta?
Your voice was cracking for me.
Okay, beta. So what is the net displacement? When the particle completes one revolution and reaches the point A again.
So 0.
Which means your V average is 0.
Yes, sir.
What about average acceleration, beta? What is the average acceleration when the particle makes one complete revolution and reaches the same point again? The curve. What is the average acceleration? Stick with the definition. That's why I'll say.
So should it be 0?
It should be 0. Absolutely, it should be 0. The velocity, again Vj cap. Initial velocity was Vj cap. So the Vf minus Vi then will be 0. Shavi, is that okay, beta?
Yes, sir.
Good. Let's take a quick crack at this question. Change in velocity. Change in velocity. And they're interested in the magnitude of it, not the vector, not in the vector unit vector notation.
So 10 meters per second.
10 meters per second. Baby Beta, is this how you're approaching it?
Yes, sir.
Okay. 1 by 2, so this is 1 by 4, and this is 1 by 4, so that is 1 by... Huh. You had 10 meter per second.
Yes, sir.
Am I missing something here? This should be... Oh,
Sir,
this will be 3. Sorry, my wrong. This will be 1. My wrong. This will be 3 by 4 plus 1 by 4. That will be equal to... Yes. Okay. Correct, Beta? Can I move on?
Yes, sir.
Okay. Good. Now let's go ahead and get into something fairly interesting. Seems like I might fall short of the aspiration today, but it was a pretty being able to cover the question type 20 would have been. So let's get into relative motion. Now we're going to talk about, let me see what's going on here. There it is. So let me read through the green box here. It says, in the scenario A, given two particles initially a distance d away from each other and moving at constant velocities in opposite direction, determine the time taken for the two to meet. Assume that there is not much of a distance between them, between their paths, right? So assume that they are almost head on. So A is one-dimensional scenario. The second one is the two-dimensional scenario. System seems to hang up with all the streaming and Google Meet all going on at the same time. Okay, so one is if the two trains are headed towards each other. Let's say the velocity is VA. This is my train, whatever the other object is. This is A, and the other train or the other, whatever the object that you want to think of, that is this direction. What will be, how much time will it take for them to collide if the distance between them at time t equals to 0 is d? What will that be? So let's think from the size of B. What will B see, right? If we truly were to take away all the references on the ground, then B wouldn't even realize that it's moving, right? So what B will see is that A is headed towards it with how much velocity? What is the relative velocity of A with respect to B? Is it VA plus VB or is it VA minus VB?
Plus.
Plus, right? So relative velocity is VA minus VB, but the VA vector is pointed towards the negative y direction if you assume that the positive y direction is pointed upwards. So in this case, it will be minus VA. And VB, of course, was the positive. So then it will be simply be minus V. Or VA plus VB. So the magnitude is VA plus VB. So what will, let's say, if you were the B particle, what will you take? What will you say the time it will take for A to reach you, right? Simply distance d divided by the velocity that you are seeing it, VA plus VB. Yes? Correct, Peter?
yes, sir.
Second would be simply be d divided by VA plus VB. Now, if you were to approach it from the reference of the ground, let's say the observer is standing on the platform, right? This is where the observer is. Then observer will say, oh, actually we meet somewhere over here, right? Let's say this distance, so A travels distance S before it hits the B. And so the B would cover a distance of D minus S, right? Now, the observer will note that actually the event has happened in how much time? Well, you will say the event has happened in time S by VA, which should be equal to, wow, the system is really slowed down. Okay.
Sir?
Yes.
Sir, your voice is breaking, I think.
My voice is cracking. Is it better now?
Yes, sir.
It's not better?
Sir, it's lagging, I think, as well.
Okay. Do here. Can you guys see the screen okay?
Yes, sir.
Okay. So let me just continue. And Chavi beta, do interrupt me if it is hard to understand me, okay?
Yes, sir. So can you just repeat the last thing that you said?
Okay, so I said now let's look at the same situation from the reference frame of the ground of an observer standing on the ground, on the platform. What will they report? They will report that yes, the event has taken place in time t, but the particle or the train A has traveled a distance s and B has traveled a distance d minus s. Correct? So what will be the time taken? Well, that will be s by VA, which should be equals to d minus s. Yes. Correct, Namita?
Yes, sir.
Okay. This should be equals to the time t. Correct, Namita?
Yeah.
So I can say S is equals to VAT, and we can say D minus S is VBT. Just add to what do you get? Distance D is equals to VA plus VB. Simple math. This is, I'm sure you guys would say, this is kids stuff, right? We do that in class 8th perhaps, right? Same thing, no? Same time duration. Now let's talk about the two-dimensional scenario. Now let's talk about the two-dimensional scenario. So let me enlarge this image because we'll need it. Okay. So let's see what do we have here. What we have here is we have, let me just check. Yep, I can, it's visible. So you have these particles, particle 1 and particle 2. Particle 1 is moving in this direction with V1. Particle 2 is moving in some other direction with V2. What we're trying to find out is the minimum distance between them, right? Because the chances that they're colliding, we'll talk about the where they collide as well. So we'll talk about that as well. But now let's first begin with the more complex scenario. So we're gonna deal with the simple scenario. We just want to gonna head on and deal with the more complex scenario. So let's say the nearest distance is when this part here, particle 2, and particle 1 is here. This is the distance. This is the nearest distance that they ever get to each other, right? And we want to find that distance. Here, relative motion is the concept of relative motion or relative velocity will come in very handy. Okay, let's see. Let's say you are sitting in the reference frame of V1, right? Look, so from the perspective of V1, V1 is stationary. Particle 1 is stationary. Let's see as the velocity of, we'll see V2 minus V1, right? Where is the minus V1 vector? Like this. Correct, Namita? Chavi?
Yes, sir.
So one will think that actually it is moving in this direction. Okay. So initially at time t equals to 0, when we started to observe the motions along certain distance, if the coordinates are x1, y1, coordinates are x2, y2, so I can call this as r2 minus r1. Yes? R2 minus R1 vector. Okay, this is R2 minus R1 vector, beta. What is the direction? Tail at 1, head at this one. Let me use a different color. So this is my R2 minus R1 vector, right? What is R2 minus R1? The relative or the position vector of 2 with respect to 1 when at time t equals to 0. Okay. Now look at what A is seeing now. A thinks it's stationary. A sees this is this far away, right? And A sees that this is moving in this direction. What will be the nearest point? This point will be this one, right? This will be the nearest distance, which is what. Is this part clear?
Yes, sir.
Okay. Well, if we knew this angle theta, we would be quite okay. Yes, Betaji?
Yes, sir.
Okay. Okay. So let's look at the angle between these two vectors. Which two vectors? This is minus V1. And I'm gonna flip this position vector, R1 minus R2 vector. R1 minus R2 vector is in the direction opposite to that of R2 minus R, right? This is R1 minus R2. Now I can use A dot B equals to AB cosine theta to figure this angle out. Yes? So this angle is theta,
Yes, sir.
right? This angle is theta. Then what is cosine theta? Cosine theta would be the V2 minus V1 dot product with R2 minus R divided by the magnitude of the two vectors. Yes, Betaji? All well done?
Yes, sir.
Okay. Now this is cosine theta. What do we need? We need R2 minus R1 sine theta. Right? So what is D? D is R2 minus R1, magnitude of this vector sine theta. Correct, beta? So if you know cos theta, you can figure out sine theta, and from here you can figure out this distance. Yes?
Sir,
Yes, beta?
sir, So after you found the position vector, the r2 minus r1, I did not understand how you got the velocity part.
Sorry, Beta. First of all, I need to correct this. I wrote as R1 minus, should be R1 minus R2. That's what I wrote here. Sorry, Beta. Tell me one more time. What's the confusion?
So I didn't understand how you got the v2 minus v1.
Okay. V2 minus V1 was the relative velocity vector. Velocity vector, remember this one? This was V2 minus V1, no? So according to according to particle 1, the particle 2 will follow this path. That's how one will see it, relative to itself. Okay, relative to the ground, they're going to follow different paths. Relative to the ground, 2 is going to follow this path. But relative to 1, this is how one will see the particle 2 passing by. Yes, Beta?
And sir, r2 minus r1 is
R2 minus R1 is what? It is the position vector of 2 with respect to 1 at time t equals to 0. Right? At time t equals to, where is 2 with respect to 1? It is at a distance of R2 minus R1, magnitude of R2 minus R1 vector. Right?
okay. Yes, sir, got it. Yeah.
Got it?
Yes, sir.
Notes in the green book. Once you'll get it, you'll get it. It's actually fairly simple steps. So if you see what I've not written too many steps, no? They look like scary vectors, but they're not that scary either. It's just a matter of getting used. Okay? We're gonna stop here. We're gonna take a break. We're gonna carry on Monday. But make sure that you guys have solved on this, that we do not start cold on Monday. Do practice some questions. If you struggle, look at the solution given there. If it doesn't make sense to you, send me a voicemail or send me a voice message over WhatsApp. I'll try and respond. Okay? But I think you guys will get it. Chavi beta, this is important. Okay? Ruchika beta.
Yes, sir.
How comfortable are you here? Scale of
Sir, fully 4.5.
4.5. Chavi beta, how comfortable are you on the scale of 1 to 5?
So with this specific thing,
Yes, beta.
not very, sir. But I'll go and look at it today, right now, and then
Yes,
I'll.
beta. Yeah. Chhodna nahi. Today itself you have to go and resolve it. Otherwise, as I mentioned, these things cause unnecessary psychological pressure, right? Which we don't want. Get it resolved if you struggle. Okay?
Yes, sir.
And Monday, we'll start with a question that I'll take from the JEE Advanced Practice Problems. Just on this one. So that way I would know if you guys are fully comfortable or not. With that, beta, you guys take care. I'll see you on Monday for physics class.
Thank you, sir.